Okay, so we'll take our quick look at the calendar. Just finished test number 1. Everybody should have their test back. That's yours to keep. We are now starting a brand new packet and brand new material for the second test. Second test is a ways away. It's on November 17, but it's going to be only on the stuff that we're doing starting today. Okay, so that next test is only on the material starting today. You can see what word appears in our next 4 classes. Apportionment. So that's our next major topic. It's the next 2 weeks of our class. Stuff about apportionment has a lot to do with history, and in fact, you'll see some notable American history figures named in our sections coming up. And then our next section after the apportionment all has to do with kind of sequences and population growth, and then this nature business. Like all 4 of those classes are kind of related too. So we've got 8 classes coming up of new material before the next test. Apportionment, and then sequences / population stuff. So 2 main topics coming up. And just wanted to remind you that also coming up is Election Day. It's still November 4. And I'm still happy to give extra credit if people get registered and then vote. 5 points for showing me that you're registered, and then another 5 for actually going out and voting on November 4. Now, the registration process is not an instantaneous one, and it doesn't happen online. It happens through snail mail. So the powers that be recommend that you have at least 3 weeks between when you mail your thing in and the election. So the election is 3 weeks from yesterday. So if you're going to get this ball rolling, then you need to do it ASAP. All right. If you need more info on how to do this, let me know, and I will tell you where the website is that you should go to. Okay, so let's jump into the top on page number 7. And we'll start up here with Ricky for number 1. Okay, everybody understand the setup? How many kids? 5 kids. How much candy? 50 pieces of candy. If we're just divvying them up like evenly, then everybody gets 10. But we're not just going to give everybody 10. We're going to make these kiddies work for it, all right? And so based on how much time they work compared to their siblings is going to determine how much candy each person gets. So here's the data. The first row is the name of the child, conveniently named A, B, C, D, and E. And then the minutes worked is down here. And altogether, the 5 kids worked a total of 900 minutes, okay? So your job in your groups is to spend a few minutes trying to figure out how much candy each of these 5 kids gets based on how much work they did. So talk to your neighbors for a couple of minutes, see if you can get some distribution. Okay, so let's come back together. We had a few different kinds of solutions here, but I think ultimately we all got to the same numbers in terms of how much candy each person gets. So how much does Alan get? About 8. Now, anybody have a more accurate? Is it like? All right, so 8 1/3, 8.5, just 8. Yeah. Yeah, and so, okay, so the fact that we all got something near 8, it probably means we all did reasonable things, but there's this rounding issue, right? So the rounding issue, like, you know, is it possible to give 1/3 of a piece of candy or half a piece of candy? Maybe, but maybe not. And the next example we do, the answer is going to be definitely we can't give fractional parts. And so this whole fractional part, which normally isn't that big a deal, it's just a rounding thing, is actually the heart of a lot of controversy in U.S. history and trying to come up with ways to give out seats in the House of Representatives. And that's sort of the heart of these next 2 weeks of classes is what do we do, because the answers aren't whole numbers. So let me, regardless of how you got to one of these numbers, I'm going to get you guys there to the same number in a slightly different way, and it's a way that we're going to be using a bunch here. So here's what we're going to do. We're going to take the 900 total minutes, and we are going to divide it by the 50 pieces of candy. And is that 18? So 18, okay, now let's get some units here. 18, what? 18 minutes per piece of candy, says Eric. Is that right? Those are the units, right? Now, it's totally fine that nobody in here got to the number 18. I didn't ask you to get to the number 18, but knowing this number kind of gives you another way to think about how you'd solve the problem. What would we do to figure out how much candy Alan has earned? 150 divided by the 18, right? 100, how many groups of 18 minutes did he work? It's 150 divided by 18. So let's do that then. So for Alan, we go his 150 minutes divided by the 18, and what is this? 8 1/3. Okay, so it still gets us to the same answer. We still have to figure out what to do with the 1/3, but I'm just giving you another way that's going to get us to that same answer that turns out to be kind of the quickest way to get there. And so this is something that we're going to be doing a bunch over the next few classes. So we took the total number of minutes divided by the number of pieces of candy, and then got this kind of how many minutes do you need to work for a piece of candy? And then it was quite natural to get to the 8 1/3. Okay, so on the next page, we'll go to number 2. And Monica, can you read 2?
To be apportioned among 6 states, 4 states of their respective populations was the correct apportionment.
Okay, so we're going to all do this one together, and we're going to do it the new way, the way that we just described on the last page. So first of all, do we recognize this is quite equivalent to the candy example? We don't have kids in this case. What do we have? We have states. Right? We have 6 states instead of the 5 kids. And we don't have candies to give out. What do we have? We have seats in Congress. And instead of looking at how many minutes the kids work, what are we looking at for each state? Is their population. So the words change, but the scenario is exactly analogous, right? I'm just trying to divvy these things up in some fair way, and proportional seems to be the fair way. So we're going to take this 12,500,000, and we're going to do what with that number? Divide it by the 250. We're going to take this total, and we're going to divide it by how many things we're giving out. Just like we had 900 minutes, and we divided that by the 18 candies. We're going to take the total 12,500,000, and I'm going to put some units on that guy. What are the units for the 12,500,000? That's people. And then we're dividing it by the 250, and what are the units there? Seats. All right, somebody help me out here. How many times is that? How much? 5,000 or 50,000? 50,000. Okay, and the units will help us understand what that number is. People per seat. For every 50,000 people you have, you get a seat. And so this number that we just found is important, and it's given a name, and it is called the standard divisor. I think when I retire, I'm going to form a rock band, and we're going to be the standard divisors. That's a good name. Okay, and so then to find the number of seats, we just take each of the state's populations and do what with this 50,000? As we divide. So I'm going to try to squeeze this in. You might not have enough room, but I'm taking each of these guys and dividing by the 50,000. And so maybe you guys can do that at your tables, split up the work if you have multiple calculators, and then we'll just get the answers up on the board. Okay, any questions on getting these numbers? Hopefully it's reasonable, right? If every 50,000 people gets you a seat, we take how many people you have and divide by 50,000. That's how many seats we have, right? All reasonable. Okay, if we added these numbers up and we added them exactly, no rounding, what would we get if we added all these greens? 250, right? If you add those green numbers, you get 250 because you divvied up exactly 250 seats. The problem is we can't give out 0.92 of a seat, and we can't give out 0.72 of a seat either, all right? So these green numbers, yeah, we're going to have to do something, and rounding is certainly a natural thing to do. These green numbers are also important. They are the standard. Multiply them by the. Yeah. Multiply it so they're all whole. Yeah. Okay, so what if I take those green numbers and multiply everything by 100, say? Okay. So then what would happen? Okay. Right. So is there anything wrong with what Zeke is suggesting? Can we just multiply everything by 100? I mean, 100 might not get. Was that exactly 3292, or were there more? They're all exact. Okay, so if we just multiply everything by 100, including the 250, right? So now we've got 25,000 seats for giving out. Then you're right. That's the solution. I never thought about that solution.
That would be impossible.
That's great, right? This is a way to handle it. If we just increase the number of seats we're giving out, we can find some magic number where everything goes in evenly, at least for these numbers. If it wasn't just 0.92, but actually like 5 digits after the decimal point, now we're talking like 1 million congressmen. Some people argue that 100 is already too many, so it's a great solution. I never thought of that before. It's perfect. It might not be realistic, but big government, as Eric says. Okay, so what we're going to do is assume that we cannot change the number of seats, that 250 is fixed, so we got to figure out how to give the fraction seats out in some fair way. But the green numbers here, which are like the exact answers, are called the standard quotas, all right? It's like, hey, if we had everything perfect, this is exactly how many we could give out. We can't, unfortunately, because it's fractions, but that would be like the ideal number to give out. Okay, so the big question is down here in right above number 3. We can calculate the exact number of seats everybody should receive, but the problem is we can't give partial seats. So we've got to come up with some solutions. Zeke just presented one. We're going to talk about several others. Okay, some vocabulary. The states is the term that we'll use to name the parties that have some stake in the apportionment. It wasn't states in the previous example, it was kids, but we'll just call them states. And then we've got seats, which are identical, like the pieces of candy we were assuming were identical. Indivisible is a key word here. We can't break up a seat. Maybe you could cut up a piece of candy, but the problem that we're going to have is that we want all whole number solutions. And then an apportionment method, so here's the word that's in our next 4 classes, is just a systematic method that divides the seats among the states. One way to do it would be to give all the seats to the very first state. Give A all 250 seats. That's not a good apportionment method. I don't think anybody would argue that's a fair apportionment method, but it's a method. And so we're going to come up with a method, several different methods that divide up the seats. Standard divisor we just talked about, but I'm going to highlight here that it is always a ratio of the total population to the total number of seats. Total population to number of seats. And that's exactly what we did first, right? What was our first division? What divided by what? 12.5 million divided by 250. It's always the population divided by the seats. Standard quota, we just saw, those are the exact number of seats that everybody should get if the things were not indivisible. So we're going to get fractions, and the next 2 weeks is about how do we handle those fractions fairly. And then upper and lower quotas we haven't talked about, but the lower quota is the standard quota rounded down. So let's see what that means in real numbers. So let's, we're just going to fill in here something. LQ is going to be called lower quota, and we'll fill it in formally soon enough. But it just says take all those green numbers, the exact numbers, and just round them down. The word round is misleading because you guys have something in your head that says if you're at 5 or above, you go up. Forget that. This is just round everybody down. So 32.92 rounded down is 32, even though it's really close to 33. And then 138.72 becomes 138. 3.08 becomes 3. Okay, so everybody just rounds down, and that's fine. And then the same kind of thing, we could just round everybody up. Yeah, Jen? Yes. Yeah, the lower quota is always just the number without the decimal. Mm-hmm. Right.
Because you have 250, and then if you push everybody up, you're going to have more than 250.
Yeah, like this isn't a great way to do things either. Let's round everybody up for some upper quota practice. 32.92 becomes 33. 138.72 becomes 139. 3.08. 4. I mean, like, if we really give that state 4, they've really gained quite a bit because they had hardly any more than 3, but upper just says round up, lower says round down. And Sam here has talked about, like, the basic problem is that if you just give everybody their lower quota, we will not have given out 250 seats. We'll have some left over, right? If we give everybody their upper quota, we will have given out more than 250 seats. And we've got to find some balance, some fair way to go in between. And some people are going to be winners and some people are going to be losers. Okay, so let's go to the next page and we'll actually take a look at a picture here. So let's go to Sue Ann for 4. Okay, so here's the 2012 Electoral College map. Every state has a certain number of votes that go towards the presidency every 4 years. We'll focus on ourselves over here. Massachusetts has 11. That is literally 11 people that are representing us when it comes time to vote for president. But those 11 people come in 2 different forms. 2 of those 11 are, we've got two senators, and then 9 representatives, right? 9 people in the House of Representatives. So when the founding fathers set things up, they said every state is going to get 2 senators. It doesn't matter how much population you have, everybody gets 2. But then the number of representatives you get, that depends on population, okay? And it seems reasonable that we would have many fewer than New York or Connecticut because there are many more people living in New York. That's right, and there are quite a few states that actually have only 3 people, the 2 senators and then 1 representative, and there was another clause that said every state, no matter how sparsely populated it is, will get at least 1 member in the House of Representatives. And so we look at this and we just accept at face value that somebody's done the calculations and that Massachusetts deserves 9 and California deserves, so again, there's 2 senators in there, so we're just looking at the representatives, 53. And we just trust that the census, you know, like accurately reflects Massachusetts compared to Canada, to California, and we get 9 and they get 53. But if you just thought about doing this, like if we actually had the raw data, the number of people living in Massachusetts and the number in California, do you think it would work out perfectly that we would get 9 and they would get 53? No, it's going to be the same decimal problem that we're talking about here, right? We just take for granted. Here are the numbers we see once every 4 years. Okay, it's fine. Somebody's figured it out. They just had a calculator. It's way more complicated than that because there are these fractional seats and we got to figure out who gets them. All right, moving along here. It says we'll study several historical ways that the U.S. has solved the apportionment problem, as well as looking at the current method. How do we actually get 9 and how did they get 11? Okay, so next page. First one that we will look at is named after a founding father. This is Hamilton's method. So here are the steps. You calculate each state's standard quota. And we're actually going to take a look at this table. So this is the same table that we just saw for Parador. I've already typed in the numbers, but this is what you had already that you wrote in, right? Okay, so step 1 is to give everybody, is to calculate the standard quota. That's like the exact number of seats, even though it's fractions, and that's what we're looking at now. Step 2, give to each state its lower quota. So let's actually fill in the lower quota numbers right now. 3292, everybody gets rounded down. What does this become? 32, and then 138, 341, 1319. Okay, now the total is not 250. In fact, the total is something you got to calculate. So actually do the calculations now real quick. Sue Ann says 246. Let's see if we can get somebody to confirm. All right, confirmed, but Monica's at the same table as Sue Ann, so they could be in cahoots. All right, and then Tony jumps in, like that's like I'm gonna believe him. All right, so, okay, so what does it mean? All right, so the blue numbers, this is how many seats each state is gonna get minimum. But how many seats do we have left over to still give out? We got 4 to give out. How many seats are there? How many states are there that want these seats? There's 6. You can't give to everybody, right? This is just a problem that isn't going to make everybody happy. So what we're going to do is we're going to look at something called the residue. If you're like cleaning up a mess and there's a residue, it's what's left over, right, after like the mess. So the residue is just what's left over. So that 32.92, 32 was the lower quota. The 0.92 is the residue. It's just what's left over. And then the next example, what's the residue? 0.72 and then 0.08. So just fill in the residues. It's basically just the decimal part, right? If you have a calculator, go ahead and add the residues together. You might already know what you're going to get. If you're really on the ball, you might know what you're going to get, but add them on the calculator and we'll see if you're surprised. What do we get as a total? 4. Of course it's 4. Because we chopped off all those decimals and we ended up 4 seats too short. So those are the 4 seats that we have left to give out. So here's the next thing. It says this is step 3 of Hamilton's method. We're going to give out the surplus seats, these 4 extra seats that we have, one at a time, to the states with the largest residues. The states with the largest residues get the leftover seats in order. So let's rank these numbers right here. We've got all these green numbers. Which is the biggest green number up here? Is A. So I'm going to write the word first up here. It's got to be kind of small because I'm going to put a little number in the spot. Okay, and then where's the second? Okay, so the second is D. Put that there. Second, third, F. Right, I'm just writing these kind of tiny words because I still need some space in the boxes. And then B is fourth. And then E is fifth. And then C is sixth. Okay, we're good with the ordering, right? And how many seats are we giving out? 4. So then everybody that is between first and fourth is about to get 1 extra seat. So I'm going to give them out in order. I'm just going to put a 1 there. And second gets 1, and third gets 1, and fourth gets 1. And so then if I'm thinking about, let's actually put some zeros in. 0 for fifth, 0 for sixth. And then if I'm thinking about how many seats we have all together, you take the number that you had in blue plus any that you might have just gotten in purple, and that's your total. Okay, it's really easy here, right? I mean, the first one is just 33. But part of the next project that isn't quite assigned yet, but will be next class, involves using Excel, a spreadsheet. And so I'm just starting to try to think about stuff in spreadsheet form. So adding 2 rows is a natural spreadsheet thing to do. So I'm really thinking about adding the blue row plus the purple row, and that's going to give me my total. So how many for state B? 139. C, stuck at 3. 42, that's good. Stuck at 13 there. 20. Add them up. I mean, we know what we should get, but let's just really make sure that we get what we expect. How many do we expect? Should be 250. If we've done things right, we'll get 250. And so that's our 250. Okay. So who's happy? Which states were happy in this apportionment? Everybody but C and E, right? Everybody else got 1 extra except for C and E. Now, out of C and E, which one really probably didn't have much claim to want an extra state or an extra seat? Yeah, C barely. I mean, right, the 0.08 is barely like more, like they had 3.08. That's so close to C or 3. They're probably not going to complain too much. But how about state E? They were at 13.7, which if we go by the normal rounding rules, there's no question they're closer to 14 than 13. Yeah, and that's kind of the bigger issue is that 0.7 compared to the 0.72, that 2/100ths of a seat got state B an extra seat with state E left in the cold. So even though this seems fair, still E has quite a good reason to complain. They're essentially the same population as state B, not the same population, but the same extra as state B, and yet they didn't get an extra seat. All right, with your neighbors, and then we'll come back together in a few minutes. You're going to work on this number 6. Go ahead. Okay, so I think everybody got there. Many thanks to Eric for filling in all of the numbers up here. Any questions on Hamilton's method? Shh. Any questions on Hamilton's method? Yeah, so the total should match the residue total. Yeah. Okay. All right. Moving on to number 7. Let's take a look at 7. Says we want to talk about pros of Hamilton's method. All right, so first of all, it seems fair, doesn't it? Yeah. I mean, like we had the leftovers and we ranked them and then we gave out everything we could. We weren't holding anything back. Some people are not going to be as happy as other people, but it seems maybe even if you're not willing to buy the word fair, you could at least buy the word reasonable. It seems reasonable to do this. Okay, and some people are going to gripe, but probably no matter how you divvy up those seats, some people are going to gripe. This seems reasonable, and it's also easy or at least straightforward, right? With just a tiny bit of practice, you guys are already almost experts at Hamilton's method. It's a straightforward method. Okay, so those are the pros. Turns out there are some cons we'll get to soon enough, but for right now, we'll just be happy with this method. And so we'll see some drawbacks soon enough. And what I want to do for the next few minutes is take a look at project number 2. So here's our calendar again. So that right over there says apportionment project is assigned as of next class. So coming up on Monday, the apportionment project will be assigned. That said, you could start it today and bang out a bunch of it before the weekend, to be honest. But the reason that I want to make sure that we spend a few minutes talking about the project here is that the project involves using a computer and using a spreadsheet software like Excel or Calc, which is part of OpenOffice. And I know that some people are not as comfortable with that as other people. And so I just want to give you an opportunity to really start, especially if you're one of these people that is really not a computer person. Want to make sure that you start sooner rather than later. So here's what it looks like in terms of the project. I'm not going to physically hand you anything. And you're not going to physically hand me anything when you're done. This is all going to be electronic, and you're going to email me something when you are finished with this project. So if you log into Moodle, you will find a list of your courses. Now, you're probably not as lucky as me with like all the math courses, right? You have like other, like not as nice disciplines. But anyway, so you find Math 117, you click on it, lots of stuff here. Eventually, you see some project materials. And inside of Project 2, there's, it looks kind of misleading, like these are the only 3 things related to Project 2, but there's actually a folder here, and we're going to go in there. So let's take a look inside of Project 2. And in Project 2, it talks about using Excel. There's also a free version, but if you can use Excel, that would be better because Caitlin and I have each made some videos going through how to do some related problems using Excel, and it's not exactly the same as using another piece of software. Now, Excel is a paid piece of software, so I'm not saying go out and buy it, but any computer on campus has Excel on it, and many computers in like your public library would have Excel on it. So even if you don't have it at home, you can probably find a place to do this project. So you go into the project materials and you see a whole bunch of stuff. And I want to be really clear. There's really only one thing inside of here that you need to look at, and it's this guy. And it is titled, "This document is the project," right? So I'm trying to be very obvious about what the project is. The other things are going to help you if you need some hints. I'd recommend looking through, like there's a lot of sample stuff that's quite similar to what you're going to do, but this document is the only one that is really essential. And I've opened it up right over here. And so we'll make this kind of big for you. And so here's what the project looks like. It says you're going to save the project someplace on your computer. You're going to use formulas in Excel to apportion the 435 seats that need to be divvied up in the U.S. House of Representatives. That's literally how many seats get divvied up. We have 9 of them. California has 53 of them. You got to figure out how to give those seats out in a fair way. And there's this one thing here in bold. If you do this project without using formulas, you will get an F. I want to be really clear. If you don't use formulas, you will get an F. So what are formulas? All right, down here at the bottom, you can see there's a bunch of different tabs. Right now we're on the directions page. But if you go to the Hamilton page, you will see, already typed in for your benefit, are the states of, the populations of all the states. In fact, they're even in order. So California is the most populous state. Eventually down here we'll find us. And then least populous state, Wyoming. All right? Now there's a blank here. Now that number is important, isn't it? Didn't we have to have the total population? Where did you use the total enrollment in this this problem you just did with Tasmania? Yeah, right. You needed to get the magic divisor by taking this total, the 12,500, and dividing it by the number of faculty members, right? So you need the total. So you're going to come in here to Excel, and you're going to type in one simple little thing down here. And I'm not going to tell you what it is, but you're going to figure it out. And it's just going to basically add up and tell you what the population of the US is, but it will just pop in here as a number as opposed to you trying to type into a calculator all of those numbers. That is not what I want. I want you to use a formula. Or if you're really lazy, use the button right here that says auto sum and it'll take care of it. Yes, Monica.
So you're not going to show us how to use
I am going to show you, but not in class. If you go to one of these videos, you will see, just like you could watch a video of class, you will see the actual formulas being typed in, all right? I'm just not doing it here. I don't think there's a lot of value to do it in front of you when you haven't even had an opportunity to play around with it yourself. Zeke. There are 5 methods that we're learning. You can do the very first tab, which is this Hamilton one. But most of the learning curve is going to happen in this first tab. And once you figure out the Excel pieces in the first tab, they will pretty well carry over to the other 4 methods you see down here. Okay, so you type in your formula there, you get a total. And then right here, what's this column standing for? What does SQ stand for? Standard quota, which is the actual number of seats you could give out if you were allowed to give out fractions. Now, how would you figure that out? Well, you got this blank over here that you're going to have to fill in called the standard divisor. You know how to find the standard divisor. There are 2 numbers that are going to be relevant for this calculation right here. One of them is on the screen right now, the 435, right? And the other one, you don't have yet, but it's this total that you're going to have. And then you're going to say, hey, Excel, you're going to take that number down there and divide it by the 435, and it's going to give you the standard divisor. And the good news is that even though you have no idea what Jefferson's method is, which is this next tab, it's got a standard divisor. And so you're just going to do the same. So that's what I'm saying. Like, you can do a bunch of this today, even without the details of the other 4 methods. Okay, so standard quota you've got. When you guys did the standard quota here, you actually literally typed in every state's population divided by 50, right? Or every school's enrollment divided by 50. That is not what I want you to do here. How many different states are there in this table? There's 50 of them. I don't want you typing this thing 50 times and then it's the same stuff, 5 different methods. I don't want you typing this over and over again. Part of the goal of this project is to get comfortable with spreadsheet. Excel is perhaps the most widely used piece of software out there in the business world, and you can gain a lot with a little bit of effort, and that's part of what we're after in this project, all right? So I do not want to see in here, 37253, 956 divided by whatever the standard divisor is. I don't want to see that. If I see that, you're going to get an F. What I expect to see in here is a formula. And you will learn about formulas by watching some of the videos and other resources that are there in Moodle, okay? So putting it out there, if you are one of these kind of computer phobic people, that's fine. This project is going to put you a little bit into your uncomfortable zone, but it's not the end of the world unless you wait until the last minute and then try to do it all in one shot, okay? Any questions right now on the project? The project is due way down here, November 5. Project is due November 5. Other questions on the project? Okay, so here's what we are going to do. Let's see, we did the project stuff. Great, great, great. Reading and homework. All right, so the homework is in the usual place. It is right there. We have, how long do we have? We go until 2:15, right? 2:15? Oh, I'm sorry, we go until 1:48. I must have forgotten. 2:15, that gives us 26 minutes and change to get a big chunk of that homework done. Go for it.